All right, welcome back. Today's kind of an easier day. We're going to build some trusses. Trusses are the triangular or really any type of support for structures. So, like any type of building, any type of roof, or I don't know. I guess what I said in class today, because a lot of bridges really have a lot of trusses. And usually they're triangles. It's kind of the strongest polygon. You might see some other shapes, hexagons and squares and all that stuff, but generally triangles are viewed as the quote unquote strongest of the shapes of the polygon world. That's why so many, if you look at so many side cross sections of a bridge, you'll see a lot of triangles. Anyway, enough about that. So what we have here is a roof. It says it has a pitch of 2/5, and so all that means is that the vertical change to horizontal. So vertical change to horizontal is 2/5. It's kind of like slope. It says it spans 25 or 24 feet. Cool, awesome. And then it says to calculate SPQ. So we're going to use some trig here to do that. We're going to take our, well, the SPQ is right here, right? So all I know is my opposite over adjacent. So here's my triangle. I know opposite over adjacent. Opposite over adjacent is tangent. Anytime I'm trying to find an angle, I'm going to use the inverse function. So tan to the -1 of 2/5. So I punch that in my calculator, and I get 21.8 degrees. Now, if you don't get 21.8, remember that your calculator has to be in degrees, not in radians. The next thing says draw the altitude from S2PQ. So S2PQ, right there, boom. And then it wants us to label this R. And it wants us to find SR. Well, there's two ways to do this. We can do trig, so we can do tangent of 21.8 is equal to, I don't know this, but I know half of my distance would be 12. So I'm going to multiply 12 times 21.8, and I get 4.8 feet. The other way to do it would be to do a proportion. You could do 2/5 is equal to x over 12. Multiply and do all that, and you get your right answer. Let's see, what's next? Find PS. So now I'm trying to figure out what this is. Well, I could probably do Pythagorean theorem, since I now know this is 12. I know this is 4.8, so I'd square 12. I'd square 4.8, then I'd take the square root of whatever I get, and I get 12.92 feet. The other way to do that would be to do another trig function and do cosine. You could do cosine, which is adjacent over hypotenuse. So you do cosine of 21.8 equals 12 over x, and you multiply by, well, I guess you end up dividing by 12 there. But yeah, anyway, you get the same answer, 12.92. We're not going to do D. We're not. It's kind of a waste of time. E wants us to divide PR into 4 equal segments. So I'm going to jump back and forth here so we can do this. Now, since it's 4 equal segments, that means that if this long piece is 12, that means each 4 segment is going to be 3. So from P to there, that would be 3, and the next one would be 3, next one would be 3. So 3, 1, 2, 3. Oh yeah, and then this one would be 3 as well. Okay. Next thing it says is to label each of those A, B, and C. So I'm going to erase my 3's. And that's A, that's B, and that's C. Next thing it says do is draw a perpendicular to PR. So I'm going to draw lines. I kind of already got this going a little bit. So boom, boom, and boom. And then it says to label those L, M, and N with the intersection of PS. So L, M, and N. And we still know those are 3, right? It says find LA, MB, and NC. So LA, MB, and NC. Well, let's kind of look back here for a second and let's look at our triangles. If I want, oops, sorry. I want to find LA. Well, I know that the triangle is 3, and I don't know the height, but I know that the uh, angle is still that 21.8. So in my calculator, in my calculator, I have tan of 21.8 equals x over 3. Multiply that by 3, so tan, normal tan this time, and I get 1.2 feet. Now MB is the same distance away, so 3 more, but now my triangle will be this triangle. So that my x-axis is actually 6, or my x distance is 6, not 3. So I'm going to just change 3 to 6, and I get 2.4 feet. And for NC, my x distance is now 9, and I get 3.6. And you see here that 1.2, 2.4, 3.6, we're just going up by 1.2 every time. The last thing it has us do is figure out, or first draw LB, MC, and NR. So LB, MC, and NR. And it wants us to find LB, MC, and NR. Well, we just found LA, we just found MB, we just found NC. I have 2 of the sides, so my third side is just Pythagorean theorem. So really, what I have is 3 triangles. And what I'm really trying to find is the hypotenuse every single time. So for like this first one, 1.2 and 3. And so I'm just trying to find that Pythagorean theorem. Same thing with this one, 2.4 and 3, and then the last one, 3.6 and 3. So I'll let you do all that. Go ahead and pause it if you want to work by yourself for a moment. LB is 3.23, MC is 3.84, and NR is 4.69. And if you round it differently, that's fine. You know, 3.2, 3.8, 4.7, whatever. I know I get that. And the last thing it wants us to do is complete the truss. So, you know, go ahead and do your best drawing of the same thing. Hopefully yours looks a little better than mine. But yeah, so that's that. So anytime like you're, I don't know if you're interested or not in architecture or anything like that, you could probably look into the different polygons and just kind of see which ones are used more frequently, all that stuff. If you ever go into your attic, you could probably see a lot of 2x4s and other plywood type things, and you probably see a lot of diagonals and a lot of triangles in your attic that's supporting your roof. Number 2 is your homework. See you tomorrow. Good to see all of you today. Bye-bye.